Hello friends, in this module we will be discussing about quality evaluation tests required for different packaging materials. Why quality evaluation tests? Because these tests are used to determine the quality of packaging material used for packaging of different food products. Such qualities will be mainly related to the strength of packaging materials. The quality evaluation test also helps in determining the quality between two different samples or maybe two different manufacturers or the same manufacturer and two different lots. So, thus we will be now discussing over different quality parameters like GSM, thickness, etc. The test procedures that are applicable for general classes of materials or packages are available and published in standardized form by various organizations like ASTM, that is American Society for Testing and Material Standards, TAPI, BIS, which is used in India, Bureau of Indian Standards, ISO, BS, FEFCO, it is used in European countries, PIFA, ABA, ABA, BPBMA, NFPA, etc. It is very important that the quality evaluation of packaging material should be carried out in a standard atmospheric conditions and the samples should be allowed to reach equilibrium prior to evaluation, which normally takes 24 hours. This is so because the properties of many packaging materials depend on the climatic conditions to which these materials are exposed. The physical properties of paper are affected by its moisture content, and the moisture content varies in proportion to the relative humidity and temperature of the surrounding atmosphere. In special cases, it may be necessary to check the moisture content of the test specimen in order to ensure that the climate has had its effect on the specimen. Quality evaluation laboratories are constructed to maintain the standard atmospheric conditions, and no test is considered official if conducted under any other conditions. In a number of countries, a standard atmospheric conditions has been established, that is 20 degrees centigrade and 65% RH in Argentina, Australia, Belgium, France, Germany, Netherlands, New Zealand and United Kingdom. Whereas 23 degrees centigrade and 50% RH in USA, Canada, Burma, Mexico, South Africa, and in India the prevailing standards are 27 degrees centigrade and 65% RH. Grammage test. The grammage or GSM is the measure of weight, or it is expressed as grams per square meter area of paper. Generally, it is utilized for paper and foils. In this test, the paper is cut into 10 by 10 centimeter size and then it is hung on a scale A. If the grammage is less than 100 GSM, then it has to be cut into 10 by 20 centimeter size and then hang on to scale B on the weighing scale. So, after that we will get the grammage directly, otherwise it can also be converted into grammage directly by weighing the weight, or after getting the weight it can be converted based on the area which is we have taken. If it is 10 by 10, then 100 square centimeter is area which has to be converted into grams per square meter. So, now we will discuss about thickness. Many physical and mechanical properties of paper, paperboard and flexible packaging materials are dependent upon thickness of the material. Properties like tensile strength, sealability, seal strength, moisture, gas and light barrier properties are directly related to the thickness. In case of laminates, the thickness of the constituent plies are more important as they influence the barrier properties. This test is useful for routine control. When we describe the method of test, we need to cut a piece of sample without any irregularities into the size of 10 centimeter by 10 centimeter. It has to be placed between 2 points of the micrometer. one of which has to be lifted gently to insert the paper and note the corresponding reading. The thickness can be expressed in any unit such as micron, inches, mil, etc. But we need to take at least 10 readings and then we need to average out the readings. Bursting strength of paper and paper board is determined in order to assess both strength and toughness of the material. It is essentially the ability of sample to absorb the energy. In this test, the sample is fixed between two clamps. The area exposed is 1.2 square inch. The sample is subjected to steadily increasing pressure hydraulically exerted on a rubber diaphragm beneath the sample until it ruptures. The maximum pressure required to rupture the sample is automatically recorded by a pressure gauge. This test is important because it gives packaging material the property which is required during transportation. For example, the bursting strength also helps in deciding the strength of corrugated boxes. Tear strength or tearing resistance is performed on papers and it gives an indication towards the strength of the paper. It is helpful in making selection of papers based on material for packaging purposes. The tear strength requirements may be high or low according to the end use of packaging material. This test measures the energy absorbed by the test sample in propagating a tear that has already been initiated by cutting a small nick in the test piece. The element of tearing tester is used for this test. It has two grips side by side with only small separation. One grip is stationary and is mounted on upright on the instrument base. The second grip is movable and is mounted on a pendulum. The pendulum is mounted on a frictionless bearing and swings on a shaft. The sample of 50 by 62 mm size is clamped in two grips and a cut is made using a sharp knife fixed on the tester. When the pendulum is released, it swings down on a pre-cut sample. This indicates the residential energy lost in tearing and expressed in millinewton. The next test is water penetration or Cobb test. This test measures the amount of water absorbed by the sample during penetration from one side to another. It is useful in assessing the suitability of paper and paper boards to be used for shipping containers which may be exposed to water spray. Method of test: in it, a weighed sample of clamped under a metal base plate and exposed to water for 1 minute. Paper and paper board are generally used for this test. The area exposed is 100 square centimeter. After the specific time, the sample is removed, bloated and reweighed. The difference in weight indicates the amount of water absorbed by the sample. The results are expressed in gram per square centimeter. Next test is grease resistance. It is important for packaging materials used for packing of fat-rich food products like butter, ghee, edible oil, etc. In this test, it is performed by putting 5 gram sand on a specimen through a hollow cylinder metallic piece and then topping the sand with 1.1 ml of colored turpentine dye. This is placed on a white paper sheet and specified intervals. The indicator sheet is examined for first spot and after it the experiment is discontinued. The time between the application of turpentine dye and the appearance of first stain is recorded as transduction time in seconds. Water vapor permeability. It is very important test and one of the prime functions of packaging material is to act as a barrier to gases and vapors. Many hygroscopic foods like milk powders have to be protected from oxygenated water vapor pickup. The measurement of permeability is therefore very important. The water vapor permeability may be measured by means of high vacuum techniques, although there are simple gravimetric methods available which determine water vapor transmission rate much easily. In this method, the value of water vapor permeability is determined by increase in weight of a dish filled with desiccant, for example, anhydrous calcium chloride or sometimes silica gel is also used, which is covered with the test specimen and sealed with molten wax or vacuum grease. The sealed dish is placed in a humidity cabinet maintained at 38 plus or minus 1 degree centigrade and 90 plus or minus 2% RH. And then the WVTR can be calculated as shown in the slide. Over the past decade, packages have become more complex and we are presently using the number of plastic films in packaging. Film users and converters may use a variety of instruments from high powered microscopes to spectrophotometers. However, for easy and rapid identification of films, film users and converters usually go for simple non-instrumental techniques. For identification of film, the first step in analyzing flexible film is to measure the sum of its physical properties like density, hardness, stiffness, etc. The laminates are to be determined into its separate plies so that they can be separately identified. There are several methods available to separate and isolate laminated components. They can be separated by heating on a flame or by immersing in boiling water up to 5 hours. Tetrahydrofuran vapors are used for rapid separation of different laminates. The plastics can be identified by solubility or by observation of burning characteristics, whereas color of the flame can also be utilized. The way of dripping and the order of fumes assist to identify the type of plastic used. Solubility of films in a particular solvent is an excellent and more dependable test for identification. In this test, 1 square inch of sample is put into 15 ml of appropriate solvent and heated to boiling point with proper care to prevent the solvent loss. Quality evaluation of fabricated packages. Once packaging materials have been fabricated into package, it is important to measure properties of these packages to ensure that they conform to desired specifications. These tests involve measurement of critical dimensions and one or two critical properties. For evaluation of glass bottles, the dimensional measurements are important. Height, body diameter, wall thickness and finish are measured to detect possible variations that may exceed the tolerance limits, which have been established by glass manufacturers. Adherence to these tolerance limits is an important factor in operation of high-speed filling lines. For checking body dimensions, gauges are used which have been specifically designed for each specific bottle. The capacity of glass container is measured by selecting a sample of 12 bottles at a random and checking them for volume. Pressure test. The bottles used for liquor, carbonated beverages and soda water etc. have to be withstand certain amount of internal pressure. Devices are available which subject to bottle to internal pressure using a gas or liquid. The bottles are subjected to an internal pressure of 150 kg per centimeter square for 1 minute. The temperature at which the test is carried out is very important since the bottle withstands 150 kg per centimeter square at 30 degrees centigrade may fail to withstand the same pressure at 60 degrees centigrade. Bottles which have to withstand pressure should be carefully designed. The next test for bottles includes thermal shock test. This test is performed when the bottles are subjected to sudden temperature difference during actual filling and use. In food industry, sterilized product or beverages is packed in bottles, and pharmaceutical industry, the bottles are sterilized by hot steam before use. In this test, few bottles are immersed in a hot water bath at temperature of 72 plus or minus 2 degrees centigrade for 300 plus or minus 10 seconds, and when the bottles have reached the temperature, they are taken out along with hot water inside and suddenly dipped into a cold water bath at 30 plus or minus 2 degrees centigrade for 30 seconds, and then the cracks developed are observed. The difference between the hot water bath temperature and cold water bath temperature gives the thermal shock to the bottles. The time for transfer of bottles from the hot water bath should not be more than 60 seconds or less than 15 seconds. The next test is impact test. Bottles that are used again and again, like when they are going to the market and then coming back and then again filled and sent to the market, recycling bottles, glass bottles are generally need to have this test. So, bottles that are used again and again often meets certain amount of impact in their daily use. In order to ensure that such bottles do not fail, this test is performed. In this test, a steel ball of 400 gram is dropped from a height of 10 centimeter on the bottle held rigidly. In case of milk bottles, the ball is dropped thrice on the same spot on the bottle, and the bottle should not freak or crack. In the pendulum test, the steel ball swings and strikes at the bottle held rigidly. This is the another type of impact test. To conclude the session, I would like to say that the quality inspection tests for packaging material are important for producer, consumer, and even for converter. Why? Because depending on the quality of the packaging material, the quality of product will depend. So, if we have a good quality packaging material, then we can have a good quality product which is having a good shelf life.